Hello, welcome back to my channel. I'm going to give my summary regards to the chapter 6 network layer. Start now. Uh, network layer is to end-to-end transport process using addressing and devices, encapsulation, routing, and the encapsulation. So as part of this, as you notice, we always use the encapsulation and the encapsulating in the entire CCNA1. Encapsulation is important because it hides the true identity or the true meaning or the true identification of the data that will transferred. Then addressing and devices. The addressing and devices locating the assigned IP address to a device in order to configure it and send messages to it. Then routing is a simple halfway eligible with the CCNA1. So routing is most will be more known in the next part of the CCNA. So the network layer protocol pertains with the IPv4 and the IPv6, the Internet Protocol version 4 and the Internet Protocol version 6. It is from the network layer. So encapsulating an IP, the transport layer PDU equals to segment. The PDU will transfer equals to segment, and the transport layer encapsulation from segment header through data. It is called the transport layer. The transport layer adds a header to segment can be resembled at the destination. So if the segment is sent, the segment from the source is sent, it will be transformed into bits. Then it will be resembled at the destination. If it is received by the receiver, it will be resembled again. So encapsulation, that's encapsulation. And for our encapsulating IP, the encapsulating IP. So the transport, what we call transport layer protocol, has its own segment and the data. From the network layer encapsulation, we have the IP header and the data, network layer and the IP packet. So they are quite different with the function, but they are truly connected. The segment header is connected to the data IP header. Okay, from the also what we call characteristics of an IP. So an IP should be connectionless, also best effort and media independent. Connectionless, no connection with the destination established before sending data packet. So it is now new to each other. Device is new with each other before transacting the sharing of the IP address. Then I have an example of a IP connectionless. For example, I have a letter that I want to send, and the letter will send and captured by a mailbox, then delivered by a truck, and this letter, the truck will deliver the letter to the home or the destination. It is called the IP connectionless. The data uh, passing through with different kind of connection or without solid connection, but the data still delivers. So the receiver is present, the letter arrived, the receiver can read the letter, this the sender doesn't know. So the receiver doesn't know is when it the data is coming. So from the IP connection less, also other than we have the what we call the IP best effort delivery of the packets. Packets are routed through the network quickly, and some packets may be lost in route. So maybe even you send a complete package or uh, uh, complete package or packet IP packet, but there's some times that the packet may be lost in during the route. uh, may be possible. Okay, you should check or consult with your destination or receiver if all the packets you sent is received. So in order for that, you can resend the data or the packet in order to receive it completely and clean. So uh, then another is the IP media independent. So then the IPv4 packet header, then you have the conversion of byte 1, byte 2, byte 3 to byte 4, the data sizes, and the version equal to 0 100 as far as I know. DS equals to packet priority, TTL equals to limit life of the packet, then protocols equals upper and layer protocols such as TCP, then source IP address equals to source of packet, destination of the packet. And for our IPv6 packet limitations of IPv4, IP addresses depletion, internet routing table expansion, and the lack of end-to-end connectivity. So uh, as I understood, the latest was the IPv6, and IPv6 is more efficient and more powerful than the IPv4, but still IPv4 is used. Uh, it's like in the Philippines. The Philippines is example of uh, a developing country, so that they didn't use or they didn't adopt more complicated type of technology. Somehow can be possible be adapted, but many of the IT practitioners or the Cisco CCNA certified didn't use IPv6 because it is depends on the company that they are working for. Then I have a trivia here that if the color of the if if the in the encapsulating in IPv6, if the box is color yellow, it indicates that the field names can form and from IPv4 to IPv6. Then if it's light green, name and position change in IPv6, and if it's purple blue, fields not kept in IPv6. So it is having corresponding standard or corresponding commands here. Then from routing, as I said, upon completion of as I've said, compare a host routing table to a routing table in a router. It is an example of routing. Then how a host routes. So host forwarding decision, three types of decision. So We have the local host web itself. uh, what we call itself is could be automatically if you plug keyboard just like UTP and console, it automatically giving its own IP set. Then if it is local host using console cables, UTP cables, through switches, router, and the devices, and also remote host. Remote host is particularly used when in a SSH or telnet structure. Recommend SSH for more security. Example of a remote host. Then a default gateway routes traffic to other networks, has a local IP address and the same address range on other hosts, then can take data and forward data out. So it was the default gateway. It is the you didn't have a pass. You didn't have you don't have a pass to migrate the data through LAN connection, because the default gateway will block it if it's not uh, necessary with that PC or with that switch. So using the default gateway, host default gateway. Example, the IP address of R1 interface is default gateway address of PC1 and 2. So example, brief description, that router should be configured, and router should have its own IP address. Then if it's the router, there are many router and connected with also many switch, you should know how to use the default gateway. Default gateway will help you to connect your devices more easily and efficient. Then host routing tables, then it from the host routing table, it shows the all network connected. It's mask in the gateway and the interface. Then packet forwarding decision, then also a routing table. Another description with the routing table, it routes. You need to configure a router or all the router or both router in order to make proper rotation or the proper route. You can handle routing if you can't, if you don't have a default gateway with your router, so it is much important. Then uh, as I've said recently, the remote network routing table entries, then next hop address. So next hop address is called when you are on a you have many switches and your switches is connected to another router far from another router. It is called the next hop. The hop or jumping to another router jump to another router in order to them to be connected. Then we have the anatomy of router, the CPU, central processing units or the CPUs, the OS or the operating, random access memory as RAM, and read-only memory as ROM, non-volatile random access memory as NVRAM. It is most complicated because the router having NVRAM. So it is a good experience having a uh, physical simulation happened in the Cisco lab earlier. It helps me to learn more. So the Cisco Internet Operation System, iOS, the system super used most Cisco devices regardless of the size and type of the device. So we have the what we call router memory or the RAM. Uses the following application and processes. The router memory or the RAM having iOS and running config, the running table, also the ARP cache and the packet buffering. ROM stored in the following boot up, then information that provides startup instruction, also power on self-test, post the test on the hardware company components, then limited iOS to provide a backup version of the iOS. So it is limited, it is highly private or highly confidential only for the company. So as continuation, to connect to a router, the proper use of the serial interface, LAN interfaces, and the console interfaces. So having boot set up, the using startup config and router boot processes from the ROM post, ROM to bootcamp, the bootstrap, flash, the FTP server, the NVRAM, the FTP server, and console to configuration. That's and its own version output. So hope you learned with my brief summary with the chapter 6. Hope you understand and thank you for watching.